Okay, so last time we are looking at graph, degree, and breadth first search algorithm, and so on. Now, one information I want to add about degree. So, I added this slide so you can download the latest version. Okay, so I want to deal this with undirected graph especially. So there's a relationship between the number of edges in the graph and the degrees of the nodes. As you know, the degree of a node is just the number of neighbors of a node. So for node 0, its degree is 2 because it has 2 neighbors. For node 1, its degree is 3 because it has 3 neighbors. For node 4, its degree is 4 because it has 4 neighbors. Node 6 degree is 2 because of 2 neighbors, and so on. So if you add all the degrees of the nodes and divide that sum by 2, that will give you the number of edges. That's basically because when you add the degrees of the nodes, when I say 2 plus 3, basically I am counting each edge twice. So I'm counting this edge once when I consider the degree of node 0, and I consider this edge again when I consider the degree of node 1. So likewise, when you add the degrees of all the nodes, you're basically counting each edge twice. So that is why you are dividing that sum of the node degrees by 2, and that will give you the number of edges. So this is a very good relationship we can have between node degrees and number of edges. So now we can proceed a little further on this. Now we can also compute what is called the average degree of a node. Average of something is just the sum of all those values divided by the number of such values you have. So average degree can be computed as sum of all the node degrees divided by the number of nodes you have. So now if you look from the first expression here, the sum of node degrees can be written as 2 times the number of edges. So it's simply a cross multiplication. We have number of edges is sum of node degrees divided by 2. So sum of node degrees can be written as 2 times the number of edges. Okay. And from this definition of average degree, sum of node degrees can be written as average degree multiplied by the number of nodes. So you basically want to relate these two. So sum of node degrees is 2 times number of edges as well as equal to average degree times number of nodes. So that's what I am relating here. Average degree times number of nodes is 2 times the number of edges. And from this you can calculate the average degree as 2 times the number of edges divided by the number of nodes. So this is also a very interesting relationship we can have because to compute the average degree for a graph, you need not be actually given the graph. If you are just given the number of edges and the number of nodes in the graph, you can compute the average degree of all the nodes in the graph. So for example, I could give you a small problem like this. Consider an undirected graph of 7 vertices and 10 edges. So I have given you the number of edges as well as the number of nodes. So just substitute in this formula to get the average degree of all the vertices in the graph. So it is 2 times the number of edges divided by the number of nodes, that is 2.86. So I need not actually give you the actual graph. It could be any combinations of all those 7 vertices could be connected using some combinations of edges, 10 edges. So without even looking at or knowing the actual graph, just by knowing the number of nodes and edges in that graph, we can compute what is the average degree of the vertices in the graph. And we can cross check this for this graph. If you sum all the node degrees of the vertices in this graph, it's going to be like 2 plus 3 plus 3 plus 3 and all these numbers out here. So that sum of node degrees comes out to be 20. And if you divide 20 divided by the number of vertices, that's going to give the average degree. So you actually see you have 20 here again in the numerator because it's 2 times the sum of node degrees divided by the number of vertices, number of nodes. So that is 2.86. So and again using the first relationship, once you get the sum of node degrees, if you just divide by 2, you get the number of edges. So in an exam, I could give you a very large graph, and you can get the number of edges in the graph by summing up all the node degrees and dividing that sum by 2. You need not manually count one by one for the number of edges. You could do that, but that's going to be time consuming if you have a very large graph. So if you want to cross check here for the small graph, it will be 10 edges, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10 edges. So that's the relationship. So if you just sum all the node degrees and divide that sum by 2, that will get you the number of edges in the graph. And we can also relate the average degree or compute the average degree as 2 times the number of edges divided by the number of nodes. So last time I was mentioning about the different types of graphs, and there was this notion of regular graph, which I defined as each vertex in the regular graph has the same degree. So for example, this is a regular graph wherein each vertex has a degree of 2. So we refer to something as a k-regular graph where every vertex has a degree k. So there was a typo last time for the number of edges in a k-regular graph. So this is the right number of edges. So there are a total of n times k over 2 edges in a k-regular graph, where n is the number of vertices. Now you can go back to this formula here for the number of edges and get that count there. So in a k-regular graph, every vertex has a degree k, and there are, say, n vertices. So each vertex has degree k and there are n vertices, so sum of node degrees is going to be n times k, because each vertex has degree k, so add k plus k up to n times. For n vertices, going to be n times k, and divide by 2. So that's the number of edges. So the number of edges in a k-regular graph would be n times k divided by 2. Okay. So that's something you have to know about the relationship between the degree and the number of edges. Any question? So let me just quickly save this. If you can type